Are we good to go?
Yeah, we are good to go.
All
Yeah,
right.
we are good to. Prashad, can you give me a minute here? Just give me a couple of minutes.
Sure. No problem.
Hey, Prashad. Yeah, we can go ahead.
All right. So, hello all. Welcome to the .NET training. So, here is the agenda for this session. So, today we are going to start with some of the language enhancements to the .NET framework in the recent versions. Some of these we'll be using as part of our ASP.NET topics or WCF topics. So just to make sure we all have a common understanding of these topics, I'm going to cover these. So we'll start with partial classes, how to create partial classes, what's the benefit of using them. And then I'll explain object initializers. Then we'll see how to create class properties and what is auto implementation. Then we'll see what are delegates, what is the purpose of using a delegate, and other features of delegates. And finally, we'll see what are extension methods, how they can benefit us while working with .NET. So that's the agenda for this session. So while I'm explaining each topic, if you have any doubt, you can speak up. And after explaining the particular topic, I'll be switching to Visual Studio to demonstrate that. So is that fine?
That's fine, Prashad.
All right. So let's get started with the partial classes. So this feature has been introduced as part of .NET 2.0 framework. Basically, partial classes allow us to work on the same class by two different people or even more people at the same time. So traditionally, we can create a class, and that can be inside one file, physical file, and only one person can work on it. So after you are done, the file can be taken up by somebody else, and they can continue working on it. But what we mean by saying more than one developer can work on it is at the same time. So the class can be in two different files, and two persons can work on each file, creating their own methods. So that is possible by using partial classes. So all we need to do is use the partial keyword in the class after the class access modifier specification. This is also used as part of auto-generated classes, such as Windows form or web form that we create. So when we create those objects, some code is generated by Visual Studio, that is used by the designer. It contains the object initialization, such as when you place a command button or text box. So adding that object to the form and some basic properties of that object, like what is the initial text to be displayed, or what is the background color, what is the height and width, etc. So all these are inside that auto-generated class. And I'm not sure whether you have noticed that at all or not. So we get another form open for the same Windows form, where we can start writing our own code for event handlers, or we can create our own methods. So when we execute the form, the auto-generated class and our own code is combined together to form a single class, and that's what all of those methods can be used appropriately based on the events. Let me switch to Visual Studio to show you how partial classes work. So I'm not sure what kind of Visual Studio version you have, but the one I have is Visual Studio 2010. So in which we can create programs for .NET Framework 2.0, 3.0, 3.5, and 4.0. I'm going to create a new project. So for simplicity, I'm going to use console application to demonstrate these topics. So I'll select console application, and C# is my language of preference. I'm going to target the .NET Framework 3.5. Let's call this as .NET Funda. I'm going to create this in the temp in this folder. So the solution name will be .NET Funda. Fine. Hmm. Strangely, it's taking a lot of time. All right, here is. So first, I'll show you how to work with our own partial class. Then I'll create one more project which is of type Windows Forms. And then I'll show there um, how we work with auto-generated code. So here we have this sample class created for us, program.cs. So here is main. Not in this class, but I'll create one more class. So usually we'll create the class like public class, my class, and then I can start declaring any data members and member methods. So let's say I want to create a method called method A. So it doesn't have any arguments. What it does is simply write some text to the console. Let's say there is one more method. All right. So this part is looks pretty straightforward. So in the main, I can create an object of type my class. I'll call that object as MC, and we need to instantiate my class. And on the MC, so when I type MC dot in that context menu, I can see method A and method B displayed here. So
Prashant?
just yeah.
Yeah, this is Ravi. Is there any way that you can increase your font size
Font
and
size?
yeah.
Yeah, just give me a moment. Where is this tab size, intent size?
It be under C#.
Yeah, that's it should be the editor. Let's see. It's not that very frequent that we go here.
Yeah. You understand. We'll never change the font size in Visual Studio.
Yeah, it must be plain text. Oh no. Where is this?
This is fonts and colors.
You're having fonts and colors.
Where is that? Where is that?
It's on the environment.
Oh yeah.
Size. With
Yeah. Thank you.
Okay.
Is this much enough? Let me see.
Yeah. It's a lot better.
All right. So in this way, I can invoke the method A. So this is how we work with classes. So now let's see how to convert this my class into a partial class. So we just need to add the partial keyword. So just by adding partial keyword, we are not going to break anything. We can leave this code as it is. We still create an object of my class in the same way, and we can call methods in the same way. So what else we can do by adding this keyword is within this project, I can create one more code file, class file. or I can name it as my class. This is the right way of doing it because if the file name is different and the um, class that we create inside it, if it is different, it gets difficult for you to identify uh, where the implementation of a particular class is. So here in this myclass.cs, I'm going to mark this also as partial. So the only catch here is it should be in the same namespace so that they can be grouped together. So the namespace here is .NET Funda, and in the second file also the namespace is same. So now when the class name is same, the CLR thinks it's same definition for the class, and at the time of execution it combines both the definitions. So here I'll create public void method C without any arguments, and I'll say console dot write line. This is from C. Save it. Now let's go back to this main and say MC dot. Now you can see that method C here, right? So even though it is in a different file, it thinks this method C is part of my class definition, and we can call those methods as if they are defined within the same file. So this is how multiple people can work on the same class at the same time. So while you work on this class here in this file, another developer can work on this class, adding more methods or modifying the same methods. Is that clear?
Yes.
All right. Let me execute this. So we see the output as this is from method A and this is from method C. And then the program is waiting for any key to be pressed. All right. So I'm going to go back to the presentation. Now let's see what are object initializers. So this has been introduced with .NET 3.0 language enhancements. Basically, as the name suggests, it allows us to initialize an object. So what's special in initializing an object, right? So we have been doing this by using constructors. So when we create an object for a class, by default we use the default constructor, or if we have any specific constructors, we can use that also. So that will create an object of the class and assign it to the variable that we are creating. So basically this object initializer allows us to do the same thing, but in a declarative manner. So while using constructor, we pass values to the arguments, the constructor's argument, and then the object is created. Using object initializer, we can specify for which data member we are passing the argument, and based on that, the object is created. So internally, the object initializer uses a default constructor. So you need not have multiple constructors if you want to initialize different set of data members. And Then we can create anonymous types, that is a type without a name, by using object initializer along with the new keyword. I'll show you how to create that. So let me switch back to Visual Studio to demonstrate this topic. So here we are creating an object of my class. Here we are using the default constructor, which need not be created, right? But so here this constructor, the default constructor, takes no arguments, right? So let me create one more class. We call this class as object initializer demo. So in this class, I'm going to keep the main method. And let's say I have a class here. Let's call this as initialized class. And let's say I have a public data member called integer member. Right, so I can have a constructor like this. Then say integer member equal to x, string member equal to y. Right, so this is apart from the uh, default constructor. Default constructor is again provided by the CLR. We don't have to create that unless you want to do something specific in that. So I have created one constructor with two arguments, and those two arguments are used to initialize the data members. So here I'm going to create an instance of the initialized class. I can create an object like this, or like this. No, let me set this as startup object. The program.c. Sorry. Let me create that. initialized class the default constructor without any arguments and without any code. So either I can leave it like this, or let's say 100, and then the string member to store. So we don't have to initialize that to 0 and for string to an empty string, because in .NET the variables are by default initialized with default values for their data type. So this is the traditional way of doing it. When we are creating a new object, either we use the default constructor, which is the constructor without any arguments, or we can use other constructors that accept some parameters. Now comes the object initializer. Let's say I'm going to create one more object. Okay, so let me add console.writeLine here. So basically, I'm printing the values of IC3 integer member and string member. Let me execute this. So you can see 125 and .NET as the output. So those are the values we supplied using this particular statement. So, so this is called as object initialization. We are creating an object and initializing it at the same time in a declarative manner, instead of just passing those arguments and then to figure out what's happening. Either you have to look up the tooltip for that constructor to see what is this value, where is it going, and to see uh, to which data member this value is being assigned. You need to look at the constructor, because if you have multiple integer data members, you won't know to which of those integer members this value is going to be assigned. So you need to look at the specific constructor to see what's happening in that. But here in the object initializer, we are saying to this member assign this value. Okay, and don't mistake that this object initializer is going to call this constructor, but it's going to call this constructor, and we are specifying our own values, so they will be assigned instead of the implementation we provided here. So with this, I mean, we don't have to provide values for all of the data members always. I can have another object created, and this time I'll only initialize to the integer member. And also, it's not like we need to provide value for the first one, then only we can provide value for the next one. We can directly assign a value to the string member. And you can say IC4 as you can see here in the IC4 object, I'm initializing only the string member with the string welcome, and in the output you can see the value 100 for integer member, which is coming from the default constructor, and the string welcome is stored there, which is overwriting the default initialization provided in the default constructor. All right, is the concept clear?
Yeah. Please go ahead, sir.
Okay. Yeah, there is one more thing. Anonymous types can be created. Now let's see what that is. So far we have discussed creating a class and how to initialize that using object initializer. So we can create. There is a special data type called as var. Basically, this can hold um, an object of any type. So you can have my obj. So if you store some integer value into that, so my obj behaves like an integer variable. If you store some class object, then my obj starts behaving like the class object. So using my obj, you can of course we have to do the typecasting and all. We can call those methods, we can access the data members, etc. So what I'm going to do now is, so I'll show you one example of using this IC4, right? And then I can say my obj dot, and I can see the integer member and string member, right? So that's how we can use the var data type. But here, by assigning IC4, I'm specifying that I'm going to store an object of type initialized class. But what if I don't want to create a new type like this? So I can do like this, new, and straight away start with the curly brace and say int value equal to some 111, and then say string value. Okay, and console.writeLine. So here I'll say my obj dot int value, and say my obj dot string value. So let me execute this. So here we can see 111 and anonymous display. So basically what we are doing here is we are creating a new class with int value data member and string value data member, but only that there is no name for that class. So here for this class, we gave a name called initialize class. But here I'm creating an object, but there is no name for that class. So that's what anonymous type means. And we can create that by using object initializer along with the new keyword. So the only difference between a declarative class and this anonymous type is we can't reuse it, right? So if I want to create another object, the same data members, again I have to use the new keyword and object initializer. On the other hand, if you create a class like this with those data members, you can simply use the constructor or object initializer to create any number of objects. All right. So our next topic is class properties. So these class properties allow us to get access to the private members of the class. What I mean by access is reading those private members, writing to the private members, and perform any calculations on those. So basically, private members are not accessible um, to the code outside the same class, right? For example, the main method. So even though we create an object of the class, using that object, I cannot access private members of the class. So these class properties allow us to get access indirectly, so we can read from the data members. We can use methods also for the same purpose.
Sir?
Yeah.
Just give me 1 minute, sir. Sorry, I'm sorry. Actually, I'm about to leave. Just give me a minute. I want to talk to these guys, and I'm leaving. I'll catch you tomorrow. You can continue the class.
Right.
Just give me a minute break, sir.
Sure. No worries.
All right, Prashad. Thank you. You can go ahead. Prashad?
All right, Ravi. Talk to you later.
Yeah. Thanks, sir.
So traditionally, we have been creating methods to get access to the private members. So now, instead of creating a method, regular method, in fact, a property is also a special method. Um, it contains accessors, and it behaves like a public data member. So I'll show you what I mean by behaving like public data member. So back in Visual Studio, I'm going to create new file, properties demo. All right. I'm setting the properties demo as the startup object. So here, so if you want to get the value of an integer member, you can say, sorry, similarly, if you want to write something to it, right? So in this way, we can provide read-write access to the private members. So it's not compulsory that you have to write all of these methods. You can just write the read method, and if you omit this, people outside this class can only read the value from this integer val data member. They'll never be able to change the value from outside the class. So now we are going to achieve the same thing, but instead of these kind of regular methods, we're going to use properties. So properties are nothing but special methods. So here is an auto completion feature provided in Visual Studio. So specify the data type. Basically, what I did was just give me 1 minute. Yeah. What I did was after typing prop, I pressed tab and tab 2 times. Then we can start specifying the data type. Tab to define name. Enter when you are done. So this is called as property. Now I've used the auto implemented property. So what I mean by auto-implemented property is a property contains two accessors. One is get, another one is set. So this get is actually a method, and set is another method. So for this auto interval, you can think of it as there is a data member called as auto int val, and using get, we are creating a method that will return the value of auto int val. And using the set, we are accepting a value that will be set to auto int val variable. So that is accomplished in this single statement. So earlier, we wrote one statement to create one integer variable and created one method to read the value from int val and return to outside this class, and one more method to set value into the integer value. But all of that is combined into a single statement here with the auto implemented property. So we are saying auto implemented because we are not writing any code for get and set. So this is a default implementation of the property. So if you want to create your own implementation for get and set, you can write. So whatever data type you want for your data member, string, my string val, right, and then say get, again curly brace. Within this, the get is for returning the value of the variable. Where is this my string? So to define set, again within curly braces, you say my string val equal to value. So you see that the set doesn't take any parameters, right? So how do we? So the purpose of set method is to take a value and assign it to this data member, right? So the set doesn't contain any parameters, but we get the value by using the keyword value. So in order to use this my string val, let's create an object of test class, and I say tc dot my string val equal to hello. Okay, so like this, I'm assigning a value to my string val. So if you don't have access to the code of the test class, just by seeing this code, you will think that my string val is a public data member, right? It's a public variable created within the test class, and we are just accessing that variable. But in reality, it's not a data member, but it's a property, which is a combination of data member plus accessor methods. So when we use this statement, we are actually invoking the the set accessor method So whatever value we are giving after the equal to, that will be passed on to the set and represented by this value keyword. So that will be assigned to my string value. And when we use this statement, we are invoking the get method and it returns the value of the variable. Let me execute this. Um, properties demo is the startup object. So let's execute. Something happened. Stack Overflow. Sorry. Stack Overflow. Let me set value to the auto string val. That contains hello. Yeah. Somebody has a question?
No, Prashant, good.
Okay, fine. I don't see a problem with this property. All right, I'll look into that later. Why it is giving Stack Overflow with this one. To continue the topic, so we can have both accessor methods defined like this, or we can just have one of them. So, for example, I can have only the set accessor defined within the property. So anyone can write to this data member, but they cannot read the value. Or you can just leave get. So anyone can read the value of this property, but no one can write to it. So in that way, we can control the access. There is one more way to control the access, that is by using access modifiers. So I can say protected here. So by doing so, I'm saying that only the classes which are derived from this class can set value to my string value, not from main. Okay. So like this, we can use access modifiers with the accessors. So in that way, these accessors are behaving like methods, but they are used like a public data member. So the catch here is if you are using the access modifier, you have to define both accessors. So you can't use access modifier with only one accessor defined. So only when you define get and set both, then you can use access modifiers. Okay. So in case of inheritance, you can override the accessors as well. But then you have to use the same access modifier if you are overriding the accessor. All right. So I have demonstrated how it appears as a public data member, but actually there are accessor methods which are nothing but get and set. These accessors can be configured with access modifiers like the one I showed in the last, protected, public, or private. So when we use those access modifiers, we have to define both the accessor methods. And we can have auto implementation for the properties as well. Auto implementation is nothing but this one, the get semicolon and set semicolon. So that is the auto implementation. Okay, let's move on to the next topic, which is delegates. So delegate, as the name suggests, it represents something else, and that something else is a method. So basically, delegates represent some methods. So this is similar to C++ feature function pointer or pointer to function. So there we had the concept of pointers, which can represent a function by pointing to the same memory location. So here delegates can be thought of as in the same fashion, but the additional benefit that we get here in C# is they are type safe. That means the arguments passed to the delegates, we can enforce a specific type in those arguments, and also um, we can define the return type also. So only the methods that satisfy uh, the criteria can be represented by a delegate. But in C++, it's not like that. It's just a pointer. You can point it to anything, right? You can point it to a method with no parameters. You can point it to a method with a couple of parameters. One is int and another is string. You can point it to anything. But here it's not like that. When you create a delegate, you specify the return type and the number of parameters and data type for the parameters. Then the delegate can represent only methods that have the same signature. So the purpose of delegate is and how a delegate works is by representing a method. But why we have to use a delegate, right? So in the real world, let's say you are creating a program that needs to invoke another program, right, at some point in time. But the other program is not ready yet, and you can't wait till the other program completes so that you can continue. So the way out is to use a delegate. Since you are writing the program first, you create a delegate and say whatever method that satisfies this signature can be represented, and you go on by using that delegate, by invoking a delegate. So basically you complete your program, and whenever the other program starts, they'll see that you have a delegate created and you are invoking that delegate. So they'll create a method uh, matching the signature of the delegate, and at the time of execution, your code actually calls the method in the other program, and that gets executed, right? So in that way, we can create callback methods, or it is especially helpful when you are creating add-ins, etc. And also the delegate allows creation of anonymous methods. So in the earlier topic, we saw how to create anonymous types. Now we'll see how to create anonymous methods. Let me switch to Visual Studio and create one more class file called as delegates demo. So here is the delegates demo. So under the namespace, I'll say sorry, sorry. Let me do it under the class. These can be in a separate class, just defining the delegates or int y. So we have to use the keyword delegate. Then it won't ask for implementation of the method. So basically, it's a it looks like a um, method declaration in C++. So now I can have a mm, member method within this delegates demo class. I call that method as a class method, and I'll say int a and int b. So here um, I'll return a plus b and then convert it to string. So in main, I'm going to create a variable of type myDelegate. I'll call this as md equal to. So first of all, I need to create an instance of delegates demo. Delegates demo dd new object of delegates demo and dd dot class method, right? And then say md or within the console dot write line, I'll say 0. Sorry, md. Okay, now let's execute this, and we can see 7 printed. I'm not sure whether you are able to see that, but 7 is printed there. So, so within this delegates demo class, I have a member method which takes 2 integers as parameters, and it returns a string. So within the method, it does some calculations. Finally, it returns a string. So in the traditional way, I can invoke this method by creating an object of that class and by invoking that method using the object and passing those values. But here what I'm doing is I have a delegate um, defined as with 2 parameters and return type as string. So I'm creating a variable of type the delegate, and since the delegate signature and the member method signature is same, so I'm saying this delegate represents my class method. So from that point onwards, I can invoke this method by using MD. So when I use that MD and pass values, it's going to call this class method and it will execute the code within this. Okay. Okay. So now let's see how to create anonymous methods. So for the same delegate or oh, sorry, this should take 2 values. 10 and 20. What's happening here? Unexpected delegate. Yeah. I delegate MD2. No, 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 no. Let me think. Yeah. So, um, so after the previous code, what I'm doing is creating an anonymous method. So in the earlier example, I created a method with the name class method and made my delegate represent that method. Now I don't have any method already defined. I would like to create a new method, and at the same time, I would like my delegate to represent that. So here we can use the delegate keyword in the assignment itself, and then within the curly brace, I can start writing the code for my method. So it need not be in single statement, so we can separate it out. Oops. Like this, you can go on writing body of the method. And this MD starts representing that new method without any name. So we can invoke that method by using the delegate and passing the values. So inside this method, you can create variables also if you want to, but the scope of the variables is limited to this block. Okay, so that's how we can create anonymous methods. Yeah, so there are a couple of other concepts related to delegates. One is covariance and another one is contravariance. So covariance means, so here the delegate's return type is string. Let's say that is a delegate that returns the type of delegates demo. And it doesn't take any parameters. Okay, so basically the return type is this one. Let me move it out of the class. So there is a delegate which returns an object of type delegates demo. So any method that does the same thing can be represented by the delegate now. Public delegates demo, another method, and here I'll or I can just say return this. Okay, so this keyword represents the current object of the class, which will be obviously of type delegates demo. So now my delegate, this my delegate can represent another method. So what covariance means is, let's say I have one more class called as derived class, which is extending the delegates demo. Okay, so basically I created a class from delegates demo, and I can have another set of data members and member methods within the derived class. Now let's say there's a method that returns the type of derived class. Okay, so here in the main, I'm going to create an object of delegates demo dd1 or dd2 new delegates demo. What is the new delegate name? Class delegate. Class delegate cd equal to dd2 dot another method. And I can write console dot write line cd dot toString. So here cd represents the current class. So now I'm going to show the covariance. This cd can also let me create an object of the other class, derived class dc obj. That's not to confuse between the cd and dc. New derived class object, and now this cd can represent dc obj dot dc method. Okay, so if we execute this, there are some build errors. Return type delegates demo is less accessible than delegate. DC method, DC method. Oh, yeah. Return this. Okay. So here in the output we can see in both places it is class delegate. Instead of that, um, public override toString return uh, from derived class. And in the previous one also, I'll override the toString method. from delegates demo class. Now let's execute. Yeah. Since I'm calling the toString method on the delegate, it's just converting that type um, as toString and prints class delegate name. So to print the correct value, I'll have to typecast it. But the concept I'm going to explain here is the delegate. If you look at the declaration, it is having a return value of delegates demo, which is this class. But if you look at the code here, I'm making it represent a method, the DC method, which has a return type derived class, which is different from the delegates specification. But it is accepted because the derived class is derived from the delegates demo, the type defined in the delegate. So this delegate can represent any method that has a return type as delegates demo or any of its child classes. So that is called as covariance. Is that clear?
Yes.
Yes.
Okay. Now I'll show you what is contravariance. So for this, in the delegates demo, I'm going to create a method. DD method, and it takes delegates demo object as a parameter. And I'm going to have it need not be derived. I can have a brand new class, uh, but yeah, it need to be derived. Let me public string DC method. And this takes the object of derived class. I'm going to create a new delegate that returns a string I'll call this as CV delegate, contravariance delegate. And this takes derived class as a parameter. Okay, so this new delegate takes derived class as a parameter. So let me suppress this code so that we are not distracted by that. I'll create region. All right. So here I'm going to create a variable of type contra v delegate. I think I have defined it earlier. No. Okay, fine. So this CV delegate delegates demo. I'm creating an object of dd demo. Oh, sorry, d demo, and also I'm creating an object of type derived class. So going by the declaration of this contra v delegate, I can make it represent dc2 dot dc method. No, yeah, the capital DC method. I should give it a different name. Um, what should I give? Method convert DC to string. Okay, so this is the method name. Here I don't have DD method. Okay, fine. So here DC2 dot convert DC to string. I'm creating a new object there and passing it to the. So like this, I can make it represent convert DC to string method because the delegate's signature matches with the convert DC to string method signature. It returns a string and accepts a derived class object. But what contravariance means is this CV delegate dot so let me call this also convert ddemo to string. Here I should pass derived class. Okay. Okay. So here what I'm doing is I have this delegate that accepts an object of type derived class. But if you look at this code, I'm making it represent a method convert dd demo to string which accepts a parameter of type delegates demo. But it is acceptable. There are no compilation errors here, and we can execute this too, right? And the output shows from delegates demo class, this one. So it is successfully calling this method. So even though this method's parameter type is delegates demo, we are able to make that method represented by a delegate which accepts derived class because the derived class is a child of delegates demo, right? So a delegate having parameter type as a child class can represent methods that have parameter type parent class, the base class, and that is called as contravariance. So if a delegate accepts is defined with base class, and if it is representing a child class, that is called as covariance. And if the delegate is defined with child class, and if it is representing a base class method parameter, then that is called as contravariance. Is that clear?
Okay, yeah.
Yep.
Yes, Prashant, that's good.
Yeah, one more thing to demonstrate in the delegates, that is multicast delegate. Sorry, you have a doubt?
No, Prashant, it's good.
Okay, fine, fine. All right, let me suppress this also with a region. So let's take this my delegate. So we already have a method that has the signature matching the delegate. Let me have one more method, public string um, new method int x and int y, and this will return x multiplied by y to string. Or I can just say from class method, and here from new method. So now we have two methods that can be represented by this my delegate. So I'm creating a variable of type my delegate. I'll call this as MD multicast, yeah, MD multicast, and make it represent class method. So for that I need an object of delegates demo. Let me create new object, delegates demo, td new obj, new delegates demo, right, and td new obj dot class method. So I've made this delegate object represent class method. So the point of multicast is we can make it represent more than one method at the same time, and we can achieve that by using plus equal to operator. td new obj dot new method. Now when I invoke or like this md multicast 1020, let's see what happens. So these are returning. Okay, let me. So this in this particular case, it will return only one value. Uh, Actually, it is invoking two methods, but it can return only one value. So let me print it within the same method, even though I return something. Let me print that console dot write line and the same thing. Here also console dot write line. Yeah, and just call this MD multicast. When we execute it now, we can see from class method and from new method. Let me create console dot write line, some separated there so that we can see the output separately. Okay, now let's execute. Now, what happened? So we can see from class method, from new method. So basically, when I invoke this delegate, it's calling this method as well as this method, and they are getting called in the same sequence as I have added those methods to the delegate. So first I added class method and then I added new method. So they're getting those actual methods are getting invoked in the same manner. There is one more way to achieve the same thing, that is mixing delegates, right? So here, this is one way. I'll comment this entire thing. Oops. And my delegate, I'll call this as del1 dd new object dot class method, and then I create another delegate del2 equal to dd new object dot new method. So I've created two delegates for representing two different methods, and I'm going to create yet another delegate object, and here I'll say del1 plus del2, and then invoke del3. Okay, so now when I execute, I'll again see the from class method and from new method. We are achieving the same thing, but in this example, we are combining the delegates into a new delegate. So after doing this, I can also do del3 minus equal to del1. Okay, now let's invoke del3 again with 100 and 200. Now see what happens. So it displays only new method. That means in the second invocation of del3, we have removed the representation to class method. So it is now invoking only new method. In this way, we can add and remove methods that are represented by the delegate. by using plus equal to operator and minus equal to operator. Okay. Okay. So here instead of del 3, yeah, in the previous example I've shown that plus equal to operator. Is multicast delegates clear?
Okay.
Okay, yes.
All right, so we are on top of the hour. There is one more topic to go. That is extension methods. Let me quickly cover this particular topic. So basically, the extension methods allow us to extend the functionality of existing types. So there are two ways to extend the functionality of existing types. One is either you go change the code of the existing type, or you derive another type from the existing type and add new functionality in the derived class, derived type. But extension method achieve the same thing by not doing any of that. We are not going to change the existing type, or we are not going to create a derived type, but we are extending the functionality. So that's the speciality of extension method. So these are created as static methods, but if you look at the invocation syntax, it looks like a method syntax. So while creating an extension method, the first parameter specifies for which type we are creating this extension method. And we use this keyword in the beginning of that parameter. So normally parameters contain data type and variable name. So since we are going to use the extension method and we have to say this extension method is for so and so data type, we have to use this keyword. So there is a possibility that you create a method that has signature matching an existing method within that type, right? So in that case, the originally declared method is called and not the extension method. So extension methods are not overriding the implementation of an existing method. We can't do that. So in case if you happen to create an extension method that has same signature or as built-in method, the built-in method will be called. Okay, let me show you how the extension methods work. And this is a very good feature, and you can simplify the development by using extension methods. Let's add one more class, call it as extension methods demo. So within this class, I'm going to have a public static method. I think there is a very good example. I have it here. Count words. This returns a number. So I would like to basically add a feature to the string data type. So currently the string data type has some methods like toString or split the string into multiple characters, etc. But there is no feature built in .NET Framework which gives me the number of words within a given string. So I would like to add that feature, but I don't want to mess with the .NET code which defines string data type. And also I don't want to create a new class by extending string class um, to get this feature. So this is most simple way, and it works very effectively. So count words. So this count words method should be added to the string data type. So string s. So since this is an extension method, I have to use the this keyword. So this first parameter represents what data type that the method works on. These methods can have additional parameters also. If there are any additional parameters, you can give them here. Okay, so right now there are no additional parameters. I'll say return. First of all, I need to split the given string. If there is a space, that means it's a word. If there is a comma, that can also be a word before, until that comma, or any special characters, exclamation or something like that. If they are there, that can also be a terminator for a word, delimiter for a word. So by using these character delimiters, I am splitting the given string and then return the count. So basically this split gives a string array. I'm returning the count of the string array. So that should give me the word count in the given string. Now let's see how to use this. I'm going to have main method in this. So I'll create a string variable. My string equal to hello. How are you doing? All right, and here I'll say console.writeLine my string dot ooh, yeah. Since the class was not static, this method was not exposed. Now, see my string dot, and in the, along with the string data types built-in methods, we can now see count words, and that's the beauty of extension methods. So it appears along with the data types built-in methods and properties, as if this is part of the original implementation. Okay, so you can extend the functionality of an existing type by creating a derived class, but then to use that additional functionality, you need to create an object of derived class. But here we are not doing that. We are using the original data type and then using the extended functionality called words. There are these many words in the given string. Console dot read key. Save this and set the startup object as extension methods demo and execute. So it shows there are 6 words in the given string. That 6 is because after the comma I gave a space, so it took that as one more word. Otherwise, we have hello 1, 2, 3, 4, and 5. 5 words. Okay, if I remove this space here and execute, it shows 5 words. All right, is it clear, the extension methods? Are you guys there? Hello? All right, I hope you guys are there and are able to follow the concept of extension methods.
Yes.
Hello?
Yes, yes.
Okay, great. All right. So that's all I have to demonstrate in this session.
Okay.
And
Thank you very much for your.
Prasad, hello, this is Sumit.
Yes, Sumit, go ahead.
When will this video be available for us if we want to go back and just look at the codes you've written?
When technically is available immediately.
Right.
You just need to place a request. You ask Ravi and he'll coordinate with us.
Okay.
Okay.
Thank you, Prasad.
Thank you. Thank you.
Thank you for waking
Thank
up
you very
early.
much for your time. No, it's okay.
Have
All
a
right.
good day. Bye-bye.
Yeah, you too.
Have a good day.